Properties of logarithms. In this video, we want to learn about the properties of logarithmic function or any logarithmic expression. The first two properties are called zero and identity property. What does it mean? Zero rule is for log functions when the argument is 1. We say that the log of 1 with any basis is always 0. Why? Because we say any number to the 0 power is also 1. And if you convert this one to exponential form, you will see that the b to the 0 power is 1. No matter what the b is, any number with the 0 power is always equal to 1, which means the log of 1, no matter what the base is always 0. If you look at example 1, it says evaluate each log. So and it's asking you, what is the log of 1 base 3? When you see log of 1, no matter what the base is, you say 0. Identity rule. Identity rule tells that if you find a log of a number like b with the same base, log of b base b, log of 2 base 2, log of 3 base 3, log of 5 base 5, is always equal to 1. That's why it's called identity rule, because any number with the power of 1, that's the same as itself. b to the first power, it's b. What is log of 6 base 6? It's just 1. Log of 7 by base 7, just 1. Another properties of the log, which is called the inverse properties, is when we have a mix of log and exponential function. We said that the log functions and exponential functions are inverse of each other. And if we have a composition of these two functions, we have an exponential term inside the log, or we have a log as a power of exponential term, they always cancel each other. Let's look at the first one. It says log of b to the x with the base b, like log of 2 to the third base 2. You see that we have an exponential number, which the base of that exponential term is the same as the base of the log. As long as the bases are the same, log and exponential cancel each other, so the answer is just 3. And the same here. If you see the base of the exponential number is the same as the base of the log, again, they cancel each other. For example, if I say, what is the 2 to the power of log 8 base 2? The base of the exponential is the same as the base of the log, so they completely cancel each other, so the answer is just 8. We don't need to even calculate what's the log of 8 base 2 and then find a number, put it as a power, raise it to the power. No, just they completely cancel each other as long as the bases are the same. Otherwise, you need to find, if the bases are not the same, you need to find what is the log of 8 base 2. If it's 3, put 3, and then you say, okay, what is 2 to the third power? It's whatever it is. Example 2, we want to simplify each expression. Is asking us, what is the log of 8 base 2? Since we know that 8 is 2 to the third power, because if I multiply 2 by itself 3 times, I would get 8. And I will see that an exponential term is in front of the log, is inside the log, and the base of that is the same as the base of the log. That means they cancel each other, so the answer is 3. That's another way of calculating log of 8 base 2. Part B. We have an exponential term, 3 is the base, and this log is the power. But the base of the log is the same as the base of the number. So that means they cancel each other, so the answer is just 9. Other properties of logarithm. Product rule. Product rule tells us that if we have two terms inside the log, like x and y, which they are multiplying together, if you want to expand this log and just give each of each of those separate log, instead of having log of x times y, having log of x and log of y separately, then you have to put a plus sign between the logs. If there is multiplication, we need to add the logs. Quotient rule says if you see x and y are dividing inside the log, if you separate the logs, they must be subtracted. Power rule. Power rule says that if you see a number in front of the log, that's exponential number. But the base are not the same, because we know based on the inverse rule, if the base of the number is the same as the base of the log, they cancel each other. So we shouldn't be worried about anything. But if the base of the number is not the same as the base of the log, like here, you can see the base is x, the base is b. So they are not the same. If the bases are not the same, we can use the power rule. And power rule let me to move the exponent in front of the log and just write it as n times log of x base b. And this is the property that only log function has. So every time you want to find something that's on the exponent of something and you don't know how to just move it somewhere, you can use log. Log function has the ability to move the power and just change the location of that terms to somewhere else. And one-to-one property, which means that if the log of two terms like x and y are the same, that means x and y also must be the same. Or vice versa. If x and y are the same, the log of them are also the same. And we use this property when we are solving logarithmic equation in another video. Example 3. It says use the properties of log to evaluate each logarithm. Just clean these formulas first. Okay. We want to evaluate. That means find the value. Okay. If I want to find the value, but I have to find each of them and then add them together. What is the log of 2 base 4? Or if I change it to exponential term, I have to say 4 to what power is 2? I have no idea. What power of 4 is 2? Because powers always makes numbers greater. But if you see you give a power to 4 and makes it smaller, like 2, what is that number? I have no idea. What is the log of 8 base 4? Or you say 4 to what power is 8? I don't know. I have to use calculator. But since I cannot find answer or evaluate each of them separately, I'm going to think about, can I combine them together and write them as a one single log? Maybe at that case I can find answer. And I see that both of the log have base 4 and they are adding together. Every time I see that the two logs are adding together, I can multiply those. So I can just write one log with base 4 and multiply 2 and 8. That's a product rule. And 2 times 8 gives us 16. Now, what is the log of 16 base 4? 4 to what power gives you 16? The answer is 2. Because 4 times 4 is 16. 2 times multiply 4 by itself. Now we can have the final answer. Next part. We want to know what's the log of 135 minus log of 5. Again, I have no idea what power of 3 is 135 and what power of 3 is 5. Just calculator can find. But I know that I can use the properties of the log, and whenever I see a negative or subtraction between the two log, that means I have to divide those terms. I have to just write one single log and then divide 135 by 5. And if I divide 135 by 5, the answer would be 27. Now I can find the answer. I know what's the log base 3 of 27, or 3 to what power is 27, which is 3. So if we use the properties, it helps us to find and evaluate the function. Next example, it says use the properties of log to condense each expression into a single log. Okay, we want to just write it as a one single log. Right now, I see that two log are adding together. But I want to just have it as a one single log. That means at the end, I just want one log with base 5. And everything else must go inside the parentheses. No more logs. Okay, I have to use the properties of the log. I see the two log are adding together. That means I can use the product rule and multiply them together. But if I want to use product rule, based on the product rule, no number must be in front of each log. I just have to have log of something plus log of another. If there is a number, I have to move that number first. Do you see the number? You have to move this number first. That number cannot be there when you want to use product rule. Okay, where that number goes? Okay, let's use power rule. If you see a number in front of the log, you can move it back to the exponent. Okay, you can move a 3 and put it as the exponent of b and write it as a log of b to the third power with base 5. No number in front of the log. Just bring down the log of a base 5. Now you see I have two logs that are adding together. No number there. I can use the product rule. And if I use the product rule, I can just write one single log, and then based on the product rule, multiply those together, a and b to the third power. Multiply them together. That's it. Now I have my final answer as one single log. I combine them together. Part B. Again, we want to write it as a one single log. But as I said, you can only use product rule or quotient rule if there is no number in front of the log. If you see a number, you have to move it and put it as a power. If you see a number, you have to move it and put it as a power. So you will have a log of x squared base 3. Bring down this log of y. We're not touching that right now. And then a log of z to the fourth power base 3. Now there is no number in front of each log. That means I can use product rule or quotient. If you see addition, that means x squared and y must be multiplied together. If you see subtraction, that means it must be divided. So you can just write one single log, multiply x squared and y, and divide by z to the fourth power. That's it. Now you have your answer as a one single log. In the next example, we want to, again, use the properties of log to expand each of the expression. This time, we have one single log, and we just want to expand it. That's exactly the opposite direction of example 4. In example 4, we had it in expanded form. Just write it as a one single log. Now in example 5, we have one single log, and we want to expand. Okay, to expand the first one, what is between x and y? It's multiplication. That means I have to use product rule. For product rule, I can have a log base 3 for x. I can have a log base 3 for y. And then, because of the product rule, when you see two terms are multiplying, you have to add a log. And that's it. Next example. I see a fraction. Fraction means division. Okay, so that means I have to use quotient rule. And based on quotient rule, I can have the log of the numerator minus the log of the denominator. between x and y, I still see a multiplication. That means now I can use the product rule for this part. And if I use the product rule, I can separate the logs, log of x to the 9th power, log of y to the 4th power, and then add the log. But I don't forget that I had a negative outside. So that negative must stay outside of both of them. And bring down the first term. Now to drop the parenthesis, I need to distribute the negative, and that change all the signs to negative. So what does it mean? It means that any term, like x and y, that are both on the denominator must have a negative log, and any term like z that is on the numerator must have a positive log. So you can, instead of writing this line, you can skip this line, and for every term that's on the numerator, keep a positive log, and every term that's on the denominator, keep a negative. And then the last step is just moving the numbers, the powers. And based on the properties of the log, based on the power rule, I can move all the powers in front of the log. So I have 3 log of z base 2 minus, move the power, 9 log of x base 2, move 4, minus 4 log of y base 2. This is the expanded form of that expression. And since the logs are not the same, one of them is log of x, other one is log of y, log of z, they're not the same. You cannot add or subtract them. You have to leave it. Now, the challenge problem. It says evaluate log of 11 base 3, which means find a power for 3 that is equal to 11. I have no idea. Only calculator can find this one. When I want to type this one in calculator, I know that the log key in the calculator only calculates the logs with base 10. But the base of this log is 3. How can I do that? That's the time that we use the change of base formula. Every time that we know that the calculator only calculates base 10, and we have another base, we want to change the base from 3 to 10, or from any number to 10, we use this formula. And based on this formula, if I have a log of x with base b, I can change the bases to anything that I want, to 10, to e, to whatever, and just divide the log of x by log of b with that base that I want to have. You can put ln, because ln means a log with base e, or you can put just log x and log b, which means the base is 10. For example, I want to find the answer for this one, the log of 105 base 12. I want to use the calculator, but I have no idea, because my calculator only calculates base 10, but the base of this log is 12. So I'm going to use the change base formula, and I will put log of 105 with base 10 and log of 12 with base 10. And you can skip writing 10, because every time we have a common log with base 10, you don't need to write the base. And then type this one in calculator. And in the calculator, I will type log of 105 and then divide it by log of 12. The answer is 1.873 if I round it 3 decimal digits. Next problem, I want to find the log of 8 base 3, which means 3 to what power is 8? I have no idea. I want to use a calculator, but the base is 3, so I have to change the base. I can put log of 8 divided by log of 3. Or you can put ln of 8 divided by ln of 3. That means change the base from 3 to e. ln means base e. Log with no base means base 10. You can change both of the bases to 10 or to e. Either of them give you the answer. And you can use this time ln key. So we say ln of 8 divide by ln of 3. And the answer is 1.893 if you round it. And the last part, you want to know what power of 7 is 1 over 343. I don't know. I have to use calculator. But for calculator, I need to change the base to 10 or to e. Because in calculator, we only have two keys, log and ln, which one of them base is 10, one of them base is e. So I'm going to use change base formula. The log of 1 over 343 divide by the log of 7. I can type 1 over 343 on the calculator, or I can use the quotient rule and just write it as the log of 1 minus log of 343. And I know one of the properties of the log says that the log of 1 with any basis is always 0. So I only need to find the log of 343 and divide it by log of 7. And don't forget that we also have a negative here as well. So you put negative log of 343 divided by log of 7. And the answer is negative 3.